Going through that track fight for the first one, you needed to distribute twice on the same side, combine like terms on the same side with both your variable terms and your constants. And then once you got to this step, you had choices of what you wanted to move. After you moved everything and then divided, you should have gotten x equals 4. Do we have any questions about that one? Number 2, you needed to simplify the expression. So distribute the 1/2 and the 7/4. Remember, when you're distributing, you're just multiplying across the fractions. For the 1/2 times the -8, you can think about that as dividing, or you could use your calculator. And then, same thing for the 7/4 times the 4, you can multiply and then divide, or divide and multiply, or. But the two fractions you could combine together after simplifying. After adding them together, you would get 10 over 10, which simplifies to 1. So your final simplified version of this expression would be x plus 3. Do you have any questions on that one? For number 3, it asks for the domain and the range. Domain is all of your x values, so looking left to right, furthest point to the left to furthest point to the right. So I wrote these two different ways. One is set builder notation, from -6 to 6 and everything in between are all of your x's. Or the second one is interval notation, which we'll deal more with when we get into inequalities next unit. But the square brackets, -6 to 6, means that everything in between and those are included. And then for our range, we're looking at lowest to highest, so our lowest is -5, highest is -2. Either in set builder notation or interval notation. Questions on number 3? On number 4, you needed to solve for A. Yeah. So add your 3b to both sides, and then divide both sides by 8. So your end equation would be c plus 3b all over 8 equals A. For number 5, you needed to remember that 0 is another word for x-intercept. So if you're looking for your x-intercept, your y value has to be 0. F of x is the same thing as y. So here, if we are looking for our x-intercept, change our y to be 0 and solve for x. Where we would get -9, or the ordered pair -9, 0. Do you have questions on either of those? So the last couple of classes, we talked about how to solve systems of equations by graphing and by substitution. Today we're going to talk about the last way to solve systems, and that's by elimination. So you all should have notes on your desk. It's going to look like this. So I'm going to go ahead and make sure you have these. So I'll read through this as you copy this down. So the elimination method is where you add or subtract or multiply and then add or subtract an equation or multiple equation together to eliminate a variable. Some of those words are missing from that top. I added them in. Step 1, make sure the equations are lined up. Step 2, add or subtract equations to eliminate the variable with common coefficients, is what that should have said. Step 3 is to solve the equation for the remaining variable. And step 4 is to substitute your answer into either original equation and solve for the other variable. So part of these steps are very similar to when we solve by substitution. Similar because we're substituting a number back in and figuring out what the other one is. But how we start solving it is not. This note down here won't make a whole lot of sense right now, but when we actually do an example, it'll make more sense. If there are not common coefficients, we're going to multiply one or both equations by a number to make them common. Pencil stem. Does anyone else still need this page? You weren't the only person to. Did you finish? Yeah, I'm good. Okay. So I'm going to try my best to write as small as I can in these boxes, but big enough for you to see. But if you can't see, just let me know, and I'll try and make it bigger. So we're going to start with number 1. These are lined up. The Y's line up. The X's line up, even though the numbers are different, so it looks like they don't kind of line up, but they do. And then the constants line up. So if everything lines up, then we can look and see which variables have the same coefficient for the number in front of the variable, x or y. Which one has the same coefficient?
X.
Both x's have either a 3 or a 1.
Yeah.
Y has the same coefficient. They both have 1, even though it's not there. So because they both have the same coefficient, y's are going to be the thing we eliminate or get rid of. So to eliminate these, if both of the coefficients are positive, we're going to subtract one of the equations from the other. Does not matter which one you do that from. I always just do the bottom. But I'm going to subtract the entire equation. So I put the negative out in front to kind of tell myself I'm subtracting, but put parentheses around the entire equation to remind myself to subtract everything. And then I'm just going to do it like a regular problem. Y minus y would give me 0. 3x minus x would give me 2x. 4 minus and negative 2. It would be the same thing as 4 plus 2. So this would be 6 plus 6. And then we could solve for x. So subtract 6 to both sides. And divide both sides by 2. After we find our x, we can put that back in and find y. It does not matter which of these you use. You can put it back into either one. I'm going to use this one. The bottom one. Y equals negative 3 minus 2. So y equals negative 5. Once you have your x and your y, you can put those together as an ordered pair. Yes. Yeah, go ahead.
You guys know the Three Dog Night song, One is the Lonely Summer? One is the lonely. Anyway, you're looking at these elimination games, look for the one by itself. It makes your life a lot easier. One is coefficient. Lonely number.
Anyone have questions on how we got that answer, that process? We're going to go on to the next example, number 2. Number 2's equations are not in slope intercept form like number 1's were, but that's okay. As long as they line up, that's all that matters. So here I see that my x's line up, my y's line up, my constants line up. So I can then look and see which of these have a common coefficient, x or y. X. So since x has the common coefficient, that's what we're going to get rid of. Again, these are both positive coefficients, so we're going to subtract one from the other. X minus x would give us 0. 4y minus negative y would be plus, so this would be 5y. 13 minus 3 would give me 10. If they're the same positive, subtract every time, yes. We'll get to one of those, we're going to end up subtracting as well, and that'll make more sense when we get to it. So y here equals 2. We can take this y value and put it back into one of the equations to find x. I'm going to use this one, the second one, just because it's a little simpler. Be careful with these ones where you solve for y first and then x, because your ordered pair still needs to be x, y, and not the other way around. have any questions on that one?
Is that exciting? You get to choose.
Really? No, not at all. Anyway, for number 3, these are again lined up. The only difference is we actually had coefficients for the other one, so you can see them now. Which of these have the same coefficient, x or y? Y. So that's what we're going to eliminate, our y's. These are both positive, so I can subtract one of the equations from the other. 4x minus a negative 2x is going to become a plus, so 6x. So negative, you mean? Oh, yeah. We will deal with that in a second. We're going to end up subtracting still, but it'll make more sense when we see it. 2 minus 2 will give me 0. 6 minus 18 will give me negative 12. When you get more comfortable with this, if you want to just drop the 0 and just put 6x equals negative 12, that's also fine. And then solve for x. And then you can put x back in to either equation. I'm just going to choose the first one. So 4 times negative 2 plus y. Solve to get y. You should get y equals 7. And then your ordered pair would be 2, 7. Right. So far, I'm just going to talk for a second. So far, all of our coefficients that we, or variables that we've eliminated, the coefficients have all been positive. That will not change. For number 4, everything lines up, but we don't have the exact same coefficient. We have a positive and a negative 4. Jake? It should be negative. Thank you. So when we have a positive and a negative, we're going to add those two equations together. When we add the two equations together, the positive and the negative really subtract. I know that's confusing, but we're trying to get them to cancel. If I had put a negative here, or a minus here, I would have 4 minus a negative 4, and that would become a plus, and then I would have 8 and not 0. I want to get rid of them, not double them. So think of how I could get rid of them. In this case, the only way to do that would be to add these two together. Even though when I add them, it's really 4 plus a negative. This still becomes 0. Nine plus 7 gives me 16. And 5 plus 11 gives me 6. And then solve for y. And then you can put that back into either one and find your x value.
Wait, Miss Lori,
Yes.
how do you know which is to add and which is to subtract?
You have a positive and a negative, add them together. And if you have two positives,
No, as in like in number 3, like the negative next to a negative, but then on number 4 you did a positive next to a negative. You know what I mean?
here I was eliminating the y's. I wasn't really focused on this negative.
Okay.
Because these two coefficients were positive, I subtracted. It's based on the coefficient that you're trying to eliminate, not the others. So if they're both positive, subtract. If one is positive, one is negative, add. Really, when they're both negative, you're going to subtract as well, but we'll do one of those examples so that makes sense. I'm going to choose the first one. It doesn't matter which one. So this would be 4x plus 9 equals 5. Then we can solve for x. So our ordered pair would be -1, 1.
That says 9 or what? 4x plus 9.
Times 1. 1.
Oh.
So far, do we have any questions? For number 5, these are not lined up. In the sense they are because the x's are on top of the x's and y's are on top of the y's. But the equal sign is not, those aren't lined up. So you have one or two options. You can either move 3y over to the first one so that it lines up with the second one. Or you can move this -3y over so that it lines up with the first one. It does not matter which one you do, because at the end you should get the same thing. I'm going to move this 3y over by subtracting. And then I'm going to rewrite that first equation below the second. In this example, we have the same y coefficients, and they're both negative. So the question is, what we're asking. Here, if I were to add them together, -3 plus a -3, that would be the same thing as -3 minus 3. Would that eliminate it? No. So I would need to subtract these. Because -3 minus a -3, the negative and minus would become a plus. And now I have -3 plus 3, which would become 0. So you basically do the opposite. If you have a positive and a negative, you add so that you really subtract. When you have two negatives, you subtract so you can really add. It's confusing. Yes, I know. So 2 minus a negative x would really be plus x. -3 minus a -3 would be plus 3, so 0. 10 minus 11 would be -1. subtract when you have two positives, subtract when you have two negatives. You only add when you have one positive, one negative. In this case, we're going to have fractions as our ordered pair. That does happen sometimes. I'll say rarely in our situation, but it does happen. I'm going to do the rest of this problem below this, so I have more space. And once you find this x value, you have a couple different options, actually a few different options as to where to put this x value. You can either put it back into the first one, put it back into the second one, or put it back into the equation we changed the first one to. That doesn't matter, because you should still get the same answer at the end. I'm going to put this into the one we changed it to make x minus 3y. But if you choose a different one, that's okay. If you have your calculator, you can do a lot of this in your calculator. I'm doing this by hand because I don't have my calculator up and running. So you would put this in just like you would any other problem and find out your y. You could have put that in your calculator, added, divided, all of those things. But you would have ended up with this fraction, negative 32 over 9. So at the end, your answer would be negative 1/3, negative 32. Do we have any questions on that one? You would need to create a common denominator in order to stack these two. Right now, the denominator is 1. It needs to be 3 to multiply this by 3. So far, all the ones we've done had a common coefficient. Now we're going to deal with some that don't. And we're going to skip to number 9. So number 9, your x's, your y's, your constants line up. But none of these have the same coefficient. The x's don't, the y's don't. So when that happens, you need to make them have the same common coefficient. Doesn't matter if you choose your x's or your y's. We'll do an example where they're both different. We'll do a 10 in a second. But let's say we wanted to get rid of our x's in this case. We have 1 and we have 2. If we want them to be the same, that means they would both need to be 2. Because we can't do anything really to make it become 1. So to make them both 2, I'm going to multiply this entire equation by 2. And then rewrite that underneath it. Once you have common coefficients, then the process is the same. Here, these are both positive, so you would subtract them. And then go from there. 2 minus 2 would give me 0. I'm just going to leave that blank, but know that it's 0. Negative 7 minus 6 would give me negative 13y. Negative 1 minus 12 would give me negative 13. And I could solve for y. Then when you put that back in, you have 3 different options. You can either put this back into one of the original 2, or the one that you changed. It doesn't matter which one. I'm just going to use this first one, x plus y equals 6. So my ordered pair would be 3, 1. If you have 2 equations that don't have common coefficients for x or for y, but one of them is a 1, I would go with whichever variable that is. Because then you only need to multiply one of the equations by whatever the other one is. Not that you couldn't have eliminated the y's, but as you're going to see when we do 10, you need to do something to both. Before we do 10, do we have any questions so far? Or 10. There's another example where we don't have common coefficients for x or for y. So then you get to choose, just like we did in 9. Do we want to eliminate the x's or the y's? Which would you guys prefer? Y's. Okay. So if we're getting rid of the y's here, we have a 3 and a 4. Right now, neither of those are the same. We need to make them the same. So you're going to change them both into a common multiple. So something they both go into. The lowest would work better. The higher you go, the bigger these numbers get, and then it gets a little complex. but that doesn't mean you can't go higher. So 12 would work, 24 would work, 36 would work, and so on and so on. So to get this to be 12, I'm going to multiply this entire thing by 4. To get this to be 12, I'm going to multiply this entire thing by 3. So you have to do something to both. And then I'm going to rewrite both underneath. This first one would become 12x plus 12y equals 36. The second one would become 15x plus 12y equals 30. We have both are positive y's, so we can subtract these. It doesn't really matter which one you subtract from, so if you want to rearrange it, because this 15 is bigger, that's fine, or you can just leave it. 12 minus 15 would give me a negative 3x. 12 minus 12 would be 0. 36 minus 30 would give me 6. And so for x. Now when you go to put y or x back in to find y, you have 4 different options. You can put x back into the original 2, one of those, or one of the new equations you found. Any of those, does not matter which one. I'm just going to use this first one. Let me write this down here. So 3 times negative 2 plus 3y equals 9. I can solve for y. Add 6 to both sides, divide. Yes, let me write your pass. So our ordered pair there would be negative 2, 5. Okay. We're just going to do one more example together, then I'll let you practice. Before we do number 11, I didn't write the actual order here. Did we have questions on 10? If you are in the habit of watching class recordings from other classes to compare, 4th period, when we did this one yesterday, we solved for x, or got rid of x first. So the work there is different, but we still end up with the same answer. For 11, these are all lined up. We again don't have the same coefficients for x or for y, but this x has a 1 and then this one has a 2, so I'm going to focus on those two to get rid of my x's by multiplying this one by 2, or the first one by 2, and then rewriting it underneath. And then I could subtract these equations. Two minus 2 would give me 0. In this case, -6 minus -6 would also give me 0. Because we have the same coefficient for both x and y, so they would both cancel. And then 12 minus 14 would give me -2. So I have 0 equals -2, which doesn't really equal. What type of solution would this be? A solution. This would be -6 minus -2. So anytime you start working this and end up changing one so that they're almost the same, or if you start off and they're like this, and your coefficient for x and y are both the same, but your constant is different, you're going to end up with no solution. If you change one or both of them and then solve it and everything cancels, so your coefficients are both the same and your constant is the same, you get 0 equals 0. That's going to be your infinitely many solutions case. Do we have any questions on how to solve systems of equations by elimination? Jada.
I go over that with my
So for the remainder of class, you guys have different options. You can do the remaining problems on this page. You have, there's the last page in there that has a bunch of practice problems. And then you guys have one Khan Academy on systems of equations with elimination that is due Friday, as well as one Delta Math that is due for you guys on Monday. You can work on any of those things, but make sure you're working on something math related. Anyone have any questions on what we're doing for the rest of the class? All right, you guys have this time to work, and then Jada, I'll come to you in 1 second.